Let's make a map of the world. Our goal is to take this topojson data and combine it with some projection that will translate those latitude-longitude coordinates into pixel coordinates on our screen to get a world map that looks something like this. Technically speaking, a world map is not dissimilar from a line chart in that they both make use of SVG paths to represent the marks. This line is an SVG path, and we could also represent the countries of the Earth with SVG paths. So I'm going to start by forking this example. I'll rename it to be called World Map. The first change I'm going to make here is to make this UseData hook load in the data that we need. Namely, this topojson data, which comes from the Unkpkg CDN hosting the World Atlas project. So I'll copy this URL here, and then I'll replace this old URL with this new URL. This is no longer a CSV URL, but rather it is a JSON URL. Instead of importing CSV from D3, I will import JSON, which is a very similar function, which will parse JSON data instead of parsing CSV data. When we fetch our data with this call here to CSV, I'm going to change this to JSON and then change CSV URL to JSON URL. And we don't need this row parsing function anymore, so I'm going to get rid of that. Now we can take a look at what we've got in our data by saying console.log data. At first, data is null, and then data is this object. It has a type property called topology. This is how we know that it's topojson. Then we've got this args property, which is an array of arrays that contains a bunch of these latitude-longitude coordinates. In order to make use of topojson data, we need to sort of transform it into GeoJSON in memory using the topojson library. This topojson JavaScript library, written by Mike Bostock, lets you convert GeoJSON to topojson. What we're going to use it for is converting topojson to GeoJSON in memory so that we can render the shapes. While topojson is a great file format for encoding these shapes, its data structure is not exactly easy to work with. But the data structure of GeoJSON is easy to work with because each of the polygons is represented by an array of coordinate pairs that we can map directly onto SVG paths. That's why we need to first convert from topojson to GeoJSON in memory before we start going about rendering these shapes. Topojson.feature is the function that we'll need to convert topojson to GeoJSON. I'd like to do this conversion within this UseData hook because it's really a one-time thing, and it feels like it should be the responsibility of this module. In order to use topojson.feature, we can import feature from topojson. Just like with React and D3, we need to include the script tag for topojson in our index.html. We can load that library using Unkpkg/topojson. This is unminified. Let me see if I can get a minified version of this. There it is, topojson.min.js at 21 kilobytes. And then view raw. Now this is the URL we can use. So I'll copy that. In our code, I'll make a new script tag and then paste that URL as the source. Now over in UseData, feature from topojson should be defined. Let me just check by saying console.log feature. Now if we take a look in the console, we see that indeed the function has been imported. All right, now we can use it. Instead of calling setData with the raw data that we get, we can instead make a little function here that takes as input the data, data here is the topojson data. And then we can say set data and pass in feature of data. Just to disambiguate, I'm going to call this topojson data. When we call feature of topojson data, the returned value is GeoJSON data. And when we pass that to set data, this data here will be our GeoJSON data. So let's console.log data just to have a look. It looks like something is not quite right. Let's take a look at the documentation for topojson.feature. It looks like we need to actually pass a second argument to this, the specified object in the given topology. What sort of objects are available? Let's take another look at our topojson data. In this data structure, there's a property called objects. We've got countries and land. I'd like to use countries so we can see the countries of the world. Therefore, when we invoke feature, we can pass countries as the second argument. And we can extract countries from topojson data.objects. Now, if we console.log our data, let's see what we get. Now we've got well-structured GeoJSON data, a feature collection, where each feature is going to be a country. For example, Zimbabwe has the following geometry. This array of 169 latitude-longitude coordinate pairs. All right, we've loaded the data in. Now we're ready to render it. All right, let's take a look at index.js and see what we've got to do here. I think we're going to have to gut this and remove a lot of stuff. We don't need axes, so I'm going to delete axis bottom and axis left. I'm also going to delete these files because we don't need those. Delete axis bottom. We don't need any of these imports from D3. So I'll just comment out that line. Margin, we don't need. These label offsets, we don't need. We can keep this loading phase. I think that's a nice touch. All of this logic about inner height, x-axis, y value, blah, blah, blah. We don't need any of that. I'm going to delete everything inside of our SVG except marks. I'm going to keep the marks component just because for a map there are still marks, namely it's going to be all the countries. But all of these props no longer make sense, so I'll delete those. Now we're left with a pretty bare bones program whose structure we can use. All right, index.js looks pretty complete. We're loading in the data, showing a loading screen, and if the data is there, we're creating an SVG element and rendering our marks component. Now let's change our marks component to render geographic marks. We're not going to use any of these props, but we still are using data, so I'll keep that. I'll keep this group element just so we can use the same CSS we were using before. Now I'm going to set up a structure just going on intuition that I think we're going to need. I'll bring back this data.map call, and instead of rendering one circle for each data element, we're going to want to render a path. Fill and stroke we're going to set via CSS, and D is what we're going to set using some kind of geo utility from D3. This is the overall structure that I think we're going to need, but data, if I recall correctly, is an object that has a property called features. And for each feature, we want to map it to a path. How do we get from GeoJSON to SVG path strings? There are really two elements that we need to deal with. One of them is the projection. How do we get from latitude, longitude to pixel coordinates? The second element is once we have all those pixel coordinates, how do we generate the line string that we pass into SVG paths? D3 provides utilities to deal with both of these aspects. D3Geo is the package we need. D3Geo provides a host of utilities for geospatial visualization like paths, projections, spherical math, and a bunch of other stuff. The fundamental thing we need to use is the geographic path generator, d3.geopath. Given a GeoJSON geometry or feature object, it generates an SVG path data string. To set up a geopath, we need to give it a projection. Many projections are available, such as orthographic, stereographic, equal Earth, Albers USA, Mercator, and the natural Earth projection. This snippet pretty much shows how you can use a projection to set up a geopath. Projection equals d3.geo equal Earth, path equals d3.geopath, and passing in the projection. Let me just try copying this. I'll paste that into our code, but instead of using d3 dot, I'm going to delete these d3 dots and then import geo equal Earth and geopath from d3. To be modern, I'll use const instead of var and declare two separate constants. Now we should be able to pass in our feature to this path generator. It's slightly confusing that there's a D here and also a D here, so instead of using D, I'll use the name feature, because that's really what it is that we're dealing with. Now we should be able to call path and just pass in feature. Let's see if this works. All right, we've got our world map to show up. We have connected all the dots, so to speak, from preparing the data to loading it in, to converting it to GeoJSON, to projecting it, to rendering it as SVG paths. This is the fundamental starting point for making all sorts of maps. Next, this map could use a little bit of visual polish. While it does work, this map is what I would call a first pass. The colors don't look that good, the lines are too thick, and I don't know if I like this projection. Let's tweak the colors a bit. Over in styles.css, we are setting some CSS on our marks. There's some leftover stuff for circles that I'm going to delete. And instead of stroking these paths, I'd like the fill for these paths to be that nice color. Now that there is no stroke, all of these stroke properties are not required. There's a bunch of other CSS that we can get rid of, like this stuff for the axis label and the tick text. I kind of do want to add some stroke to our marks, so let me try this color that we were previously using for the tick lines. That looks kind of nice. And then I'll get rid of this tick line CSS. This map is a bit confusing because I don't know where the Earth ends. D3 geopath supports the GeoJSON type of sphere, which is useful for rendering the outline of the globe. We can use this in our marks component by rendering an additional path where D is path of an object where type is sphere. Now we can see the entire globe, meaning the edge of the sphere that is the Earth. Let me give this a class name of sphere so that we can style it with CSS. We can also give our feature paths a class name of feature. Now we can apply different styles to these two different things. In our styles.css, instead of saying .marks_path, we can say .marks space .feature. Now these styles will apply to our countries, and we can make a similar block that applies to our sphere. I'll set the fill to be that light color for the sphere. It looks like our sphere is actually on top of our features. So let me just fix that by going back to Marks.js and putting the sphere before our features in the document. All right, that looks a little bit better. I kind of want that color to be more faded out. You can use Chrome's Devtools by inspecting the element. You can use the built-in color picker by clicking on this little box right here. Now we can very easily modify this color to see what looks good. And I would just like it to be a very light gray, just so that we can see that something is there. That looks pretty good to me. Once you've got the color, you can just copy the hex code out of this color picker, and then go back to your code and paste it in place of that other color. All right, that looks pretty good. Looking at this a bit more closely, I don't really like this effect of the outline around all of the countries, but I do like the effect between the borders. Since topojson encodes topology, we can actually isolate those paths that are borders between countries and exclude the borders that are between countries and the sea. Let's give that a try. Topojson.mesh is a function that does exactly what we want. It's useful for rendering strokes in complicated objects efficiently, as edges that are shared by multiple features are only stroked once. We can pass in a filter function to prune certain arcs. To produce a mesh of interior boundaries, which is what we want, we can use this call right here, topojson.mesh, passing a function that compares two features and returns true if they are not the same feature. Let's try applying this in our code. I'm going to copy this snippet, and then in our UseData hook, when we call setData, we can set it to be a more complicated object that has countries and also has interiors, and that's where I'll paste that snippet. Interiors can be defined as topojson.mesh, but I'm going to use the import syntax, so I'll delete topojson dot and then import mesh from topojson. Ooh, I like that word topology. I think I'll use that instead of topojson. I'll call that topology, and then change topojson data to topology. And for the object here, this is going to be countries. And this function can be expressed more concisely with ES6. I'm going to use the arrow function syntax. Then we can express, okay, AB goes to A not equals B, just like that. Now our data will contain data.countries and data.interiors. Now our code is broken because what was once just data is now data.countries. So let me just fix that over in our marks component. We can use ES6 destructuring syntax to say, okay, data actually contains countries and interiors. Instead of accessing data.features, we can access countries.features. Okay, we've got our countries back. Now we can use interiors. I'm going to copy paste that block and then change countries to interiors. This is not working. Let's investigate why. Cannot read property map of undefined. This suggests to me that interiors.features is not defined. What is interiors anyway? We did console.log the data earlier, so let's take a look at that. Interiors is actually a multi-line string. It doesn't have a features property. It is itself a single feature. Therefore, we don't even need the .map at all. In fact, we can just say this is a path where D is path of interiors. Now I think this is working. Let me test out if it's working. by giving these different class names and giving them different visual styles. I'll call this one interiors, and the class for our countries can be country. Now in our styles.css, we can change feature here to country, and now we can see that the interiors are indeed being rendered, but they're being filled. We don't want them to be filled. We can make a new block of CSS to style our interior, and the fill for that should be set to none. Or no, I think it was actually interiors. There we go. Now we can get rid of the stroke on our countries. And let me make this stroke a vivid color like red, just so we can visually confirm that in fact it's only the interior borders now. The exterior borders are not being stroked. All right, now let me bring back that other color we had. And again, we can tweak this color using the Devtools. We can adjust the stroke color on our interiors with this color picker. You know, I'd actually like to start with the color we're using for countries and then make this a lighter shade of that. So I'll start out with that color, open the color picker, and then tweak it to be a little bit lighter. That looks pretty cool, kind of neon. And you know, now that we're rendering these interior borders, we don't actually need to render all the shapes for all the countries. We just need to render the land. That would be more efficient. I'm going to change country here to land. And then in our marks, instead of rendering countries, we can render land. So we unpack land from our data, and then we use, instead of countries.features, land.features. And the class name can be land instead of country. Now we need to populate data with land over in UseData.js. We're unpacking countries from our objects. We can also unpack land and then pass land into this feature function instead of countries, and then rename countries to be land. All right, this is working. Pretty sweet. You know, I'm realizing these borders are not the right color. It looks like I forgot to copy the color back into the code. It was kind of this neon, subtle color. Yeah, for this to take hold, you need to copy this back into the code. So I'll paste that right here. And we're done. I would like to change the projection, though, to be something like GeoNatural Earth 1. I'll just copy this name here. And then in our Marks.js, I can just replace geo equal Earth with GeoNatural Earth 1 and use that as our projection. Now the map is using that projection. One last thing I'd like to do is show Graticules. Graticules are these cool-looking lines that show you where the lines of latitude and longitude are. D3.geoGraticule constructs these geometries, a uniform grid of meridians and parallels every 10 degrees. To use this, we can import geoGraticule from D3 and then render it similarly to the way that we're rendering interiors. We can invoke geoGraticule to construct a geometry generator. We can then use that geometry generator, which will return a GeoJSON multi-line string geometry. So we could say const graticule equals geoGraticule invoked as a function. And then for our path, let's give it a class name of Graticule, or how about Graticules? And D can be path of Graticule invoked as a function. And now it's rendering the Graticules. It's filling them in, so we're getting this super strange looking shape. We can address that in styles.css. by introducing a new CSS block that will style our graticules. Okay, now we're styling them the same way as the interiors. But again, I'd like to just tweak this style a bit. We can set the stroke to be just slightly more dark than the background. I kind of like the way that looks. So I'll copy this color into our graticule stroke. I don't really like, though, how the graticules are on top of the countries. So I think I'll change the order in Marks.js so that the graticules come first. Well, not first. They come after the sphere. So the layering now is sphere, graticules, land, and then interiors. All right, I'm pretty pleased with how this looks. That's all for making a world map with React and D3.